$650 billion. That's what Microsoft, Google, Amazon, and Meta are spending this year on AI hardware. And that's more than the entire GDP of Sweden. But the question is it working? Because when you actually look at the numbers, what you find is not a confident industry executing a clear plan. What you find is something close to a very expensive bet on a hardware that's going obsolete before it's paid off, powered by energy that's becoming a geopolitical constraint, and justified by revenues that are still a small fraction of what they need to make the math work. Let's start with Microsoft. Microsoft is spending $190 billion on AI infrastructure this year. Their annual AI revenue, what they actually generate from AI products, is just $37 billion. In other words, they are spending $5 on AI infrastructure for every dollar of AI revenue that they are bringing in. Google spent $37 billion in AI infrastructure in a single quarter, not a year, one quarter. Amazon's free cash flow, the money left after they pay everything, dropped from 25.9 billion to 1.2 billion year over year. That's 95% of free cash flow consumed by AI infrastructure. Now you might say, that's not crazy. Companies invest ahead of revenue all the time. That's how growth works. And you'd be right if the math worked out over time. But the gap isn't just a revenue problem. The hardware those billions are buying has a shelf life that no one's talking about, honestly. In 2023, these hyperscalers bought a cluster of 1,000 NVIDIA H100 GPUs, around 35 million in hardware alone. They put all those on their books and they are depreciating it over 5 to 6 years time horizon. But in 2025, NVIDIA shipped Blackwell. Now, the Blackwell B200, which is the NVIDIA's next generation GPU, delivers 11 to 15 times better LLM throughput and is 25 to 30 times more energy efficient in doing so versus the previous generation H100. An H100 running inference cannot compete on total cost of ownership once the data center next door is running Blackwell chips. H100 isn't broken. It's not physically failing, it is economically impaired. Now, here's where the accounting gets interesting and a little uncomfortable as well. Meta has extended their depreciation assumptions 3 times, from 4 years to 4.5 years to 5 years to 5.5 years. Each extension boosted their bottom line, their reported profits, without any change in the actual hardware. Amazon, on the other hand, moved in the opposite direction. They shortened their GPU depreciation from 6 years to 5 years. So Meta and Amazon reported a $3.6 billion in difference in earnings from the same hardware under the same condition. Well, irrespective of these accounting maneuvers, Nvidia is ready to launch their new platform Rubin early in 2026. And to remain competitive, these hyperscalers would need to invest more in AI infrastructure once again. Something similar happened with fiber optics cable in the late 1990s in the US, when telecoms laid hundreds of billions of dollars worth of fiber optic cable across the US and under the oceans, betting that internet demand would grow to fill all that capacity. When demand didn't materialize fast enough, the fiber capacity sat idle. Bandwidth prices collapsed by more than 90%, and global telecoms stocks lost over $2 trillion in market value. Today's hyperscalers are profitable businesses, not leveraged speculative telecoms. Google has 460 billion in contracted cloud backlog, real signed revenue, And the AI infrastructure has multiple uses beyond a single application. The parallel is not that this ends the same way as optics cable. The parallel is that you can build enormous amounts of infrastructure ahead of revenue with genuine demand on the horizon and still have economics go sideways if demand doesn't grow fast enough, or the technology shifts faster than the business model expected. The efficiency gains in NVIDIA GPU is one of those technological shifts happening in real time. But there's another shift happening simultaneously: the energy costs. By the end of 2025, the US electricity prices rose 27% from 2019, with local areas near the data center hubs seeking spikes up to 267%. Meta is literally exploring beaming solar power down from space to feed its data center. That is not a joke, it is a serious engineering project because the AI workloads are pushing the data centers to require gigawatt scale power. Energy is becoming a structural cost regardless of hardware efficiency gains we are seeing with NVIDIA chips. If a data center competitor can run 30 times the inference workload per megawatt and energy is your dominant operating cost, then older hardware isn't just slower, it's structurally incompetent. The gap between what this infrastructure costs and what it's generating is real, and that gap has to close somehow. But the question isn't whether that gap closes, the question is who closes it and what that moment looks like for the prices we are paying today as AI consumers. And now here's where this gets genuinely surprising. China looked at all of this: the billion-dollar GPU clusters, the capex arms race, and found a way around it. Not by spending more, but by forced to spend less. The chip ban that was supposed to slow down China may have accidentally made AI cheaper for every founder in the world. That's the next video where I go deep into the economics of China's AI supremacy. Subscribe so you don't miss it. Thank you so much for watching.